Hi guys, let's try some problems. Look the graphs, given four graphs carefully and state with reasons which of these cannot possibly represent one-dimensional motion of a particle. So four graphs are represented at here. One is position versus time, x versus t. Second, velocity versus time. Third, speed versus time. And four, total path length versus time. Four different graphs. So by using these graphs and observing by these graphs carefully, we need to identify which of these cannot possibly represented one-dimensional motion. So to represent motion in one dimension. So one dimensional motion means the object position should change with respect to time only once. So if object is moving along positive x-axis or negative x-axis at a particular time. So when time t equal to suppose 1 second, so the location of the object, is supposed to be at only one point. It cannot be two positions at a single time. So that is the meaning of one dimension. So the first graph is given that position versus time. So the graph is something like this, given a dumbbell. So this is the position versus time. According to my criteria, suppose if I take a parallel line which is parallel to x-axis, suppose at here time t equal to 1 second. Now this is the location of the time t equal to 1 second. So at 1 second the particle position is at here, okay, but at the same time 1 second this represents the particle also position at here. So it is representing two positions at the same time, two places. So this is something is wrong. So if it is particle can say at the same time but x equal to, suppose if you take 1 centimeter, this I take 2 centimeters. At the same time the particle should not be at two locations. So the A graph, it do not represent the particle is moving in one dimensions. So the graph A, according to our knowledge in one dimensions, it won't represent the motion of the particle in one dimensions. Now coming to the second graph, velocity versus time. Velocity versus time is given a circle. On a coordinate axis a circle is given. Now this is also similar. Suppose at a given time the object position at a location, it is also have velocity at one particular point. Or if we can draw same like that, suppose if I draw a line which is parallel to the velocity axis when a particular time, so this is particular time t equal to 1 second, the particle having two velocities. So these two velocities, one is positive velocity and one is negative velocity, since it is a negative graph. So at the same time it is showing two velocities, and that is also one is positive, one is negative. So if an object is moving in one dimension, at the same time it can show only one velocity, either positive or either negative, since the motion is confined to one dimensions. So the second graph is also won't represent the motion of a particle in one dimensions. So this is how we analyze. Coming to the third graph. The third graph drawn speed versus time. So time is given and speed is given something, and this graph shows that the speed value is negative. It is showing down at here. If you can see, it is showing the speed is negative. Since speed never be negative, speed always positive. Speed, a physical quantity, never be negative. Because speed formula, speed equal to distance upon time. Distance upon time, and distance never be negative, so distance always positive. So if distance always positive, speed always positive, speed never be negative. But here the graph is showing that speed is in negative coordinate. So this also do not represent the particle in one dimension motions. So coming to the last, let us check whether it will represent or not. Now the graph indicates that total path length versus time, and if you can closely see the graph, the total path length increasing and decreasing after certain time. When it comes to this point, so this is something contradictory. Suppose if this is time axis, the total path length is decreasing. How a path length decreases? So this is total path length. How a total path length, or if I say, so in this segment, the graph represents the path length is decreasing. Length never decreases. When time increases, even though if you measure the total path length of a random particle, so this kind of that, the total path length always increases, it never be decreases. So the fourth graph also, it won't represent the particles moving in the one dimensions. So I conclude that, so these four graphs, so this graph, total path length versus time, and speed, and velocity versus time, and position versus time. So none of the graph will represent the motion of a particle in one dimension motion. So this is how we do analyze. Yeah, let's see one more problem. The following figure shows the position versus time plot of one-dimensional motion of a particle. Is it correct to say from the graph that the particle moves in a straight line for t less than 0 and on a parabolic path for t greater than 0? If not, suggest a suitable physical context for this graph. So the graph is given at here, position versus time. So this is position versus time, x versus t, and they are asking the question, is it correct to say from the graph the particle moves in a straight line? So here very important point. So the important point is that the position versus time graph never represents the motion of the object. So this is one of the very important statement at here. The position versus time graph does not represent. We cannot say that by observing position versus time graph the trajectory of a moving particle. The trajectory of a moving particle. So according to this statement, this is not enough knowledge to understand the position versus time graph. By understanding the position versus time graph, the trajectory of the path. So because the problem comes, suppose here you can see that time less than 0. So first of all, what does it mean that time less than 0? Time never be 0. Okay, never less than be 0. Okay, time may be 0 if you take at initial position as 0, but less than 0. So time less than 0 means here it do not start. So that is the meaning of that. So then only you can say time less than 0. Now from the 0 to t, here you can see time greater than 0. So when time less than 0, the position is at 0 itself. It means suppose you park a vehicle yesterday. So the vehicle is at rest from yesterday to till today. So that segment can be represented in this portion. Yeah, the vehicle is at rest from yesterday onwards and today. Suppose if the vehicle is changing position on today it is started at 0 and it is changing position, so the rest of the portion will represent the change in position of the vehicle or change in position of a particle. So the time less than 0 represents which do not start. So this graph do not represent the position versus time of a particle which is a moving per dimensions. So in the t less than 0 it's a straight line, and this particular portion, this shape is called a parabolic shape. Originally mathematical, the parabola looks like this. So this entire is known as parabola, and this is a part of in that. Now if it is not particle moves a straight line, then this graph represents what? Now if I take this graph again, so this is representing something. So to this, if I can flip particular 90 degrees so that it can maybe so if I redraw this diagram as like that, so this is the coordinate axis, but this time I'm checking this time at here, and let's take x equal to 0, position is at here. Now when time is increases, the position also increases. Suppose if I draw a graph like that, just like I turn the graph, so this we can represent according to our knowledge, in the knowledge of free fall. This graph can represent the motion of a freely falling particle dropped from certain height. So just I turn the given graph, so it will changes like this, and this is representing, the graph represents the motion of an object. Here object is particle. The motion of an particle freely falling. Dropped from a tower of height. A tower of height h. Yeah, suppose if I take from here to here a tower of height h, and from a tower, if the particle is at rest, so at rest, so this is represents, so the same straight line. So when t is less than 0, so it do not fall, t is less than 0, And after, if we drop the particle, so it takes this path, the particle will fall from 0 to down. So this particle is representing a graph of position versus time, or this also we can turn like this, parabola in third and fourth quadrant. This is also a parabola, but it is drawn in the third and fourth quadrant, and this is also a parabola which is drawn in the first and second quadrant. Both are parabolas, and I can say these two are, which I am going to highlight with yellow color. So these two are just like mirror images. These two are just like mirror images. Yeah. So this graph and this graph is just like mirror image. So this graph represents the motion of an particle falling freely, drop from certain height of, from certain tower of height h. So the graph is represents of the position of versus time, but it do not representing the motion of an object which is moving in a straight line. So yet here you should remember, this is the point, the position versus time graph does not represent the trajectory. The trajectory means in which way the object is moving. So that is the meaning of trajectory. Here it is mentioned it is moving in a straight line. No, it moves in a straight line, so it always goes in a straight.